investigate the phase angle between the current and the voltage when you have an inductor in a circuit. So I will start with LT Spice. Okay. And simply put an inductor with an AC source. That's it. Just so I can see the difference in the angle. I'm going to go to wires. Click here, click here, click here, click here, click there. Hit escape. Right mouse click. Bring in a voltage source. So voltage. Put it right here. Okay. Hit escape. Let's bring in an inductor. Inductor. That's good. Put this inductor here. Hit escape. Let's get a ground going. Okay, so we're going to get a ground. Put it right here. Then draw a line between the two, basically connecting the ground reference to this terminal right here. Okay, now let's give some values. Let's start out at 600 hertz. And this would be a sine wave. DC offset of 0. 10 volt peak, that's fine. Let's put a 600 hertz. Let's do a 6K hertz. And let's do a 10 here. And let's do a phase angle shift of 0 degrees for the power supply. Okay. Let's take a 2 millihenry ideal inductor. Okay. For the transient, I am going to set up, so you go to draft, go to Spice Directive, and you will pick a transient analysis right here, and that would be 0.005. I think that would be about right for this one. Okay, I'm going to say okay, put it right here. Excellent. So now, let's go ahead and run this. And put our probe right here. I think we need to go even further down for the transient analysis. Let's go one more 0. I wouldn't be surprised if I go even further down. Let's do the transient analysis again. Run it. Here's my probe. That should work right there. Okay, so I've got a couple cycles going on in here. Okay. Now what I would like to do, so my voltage is my reference, starting at 0 shift angle. Let's find out what the current is doing. So I am going to go with my probe now and go inside of the inductor. You could do it inside of this. That is the measurement of the current. So watch this. All right, so now we're measuring current versus voltage. The point of this is to see if practice is in line with theory. Let's put a grid here. So we're going to do view and put a grid. Fantastic. Let's see when my current maxes out. This is a good one right here. The line in blue is my current. My current is maxed out at little less than 27 milliamp, right here, for this circuit. Okay. And notice when it maxes out, your voltage is at 0. This tells you that the angle, right, is 90 degrees between the voltage and the current. So the current is lagging the voltage. As you can see, the green one started out at 0 volt while the other one was still at a negative value. This is when we say the current is lagging by 90 degrees. And why 90 degrees? Again, this point right here, where the current is at 0, this one is at its maximum right here at 10 volts. Okay? So again, that I hope will drive it home to understand the phase angle between voltage and current in an inductive circuit.